Hello, this is Dr. Lori. Welcome back for our next discussion on study design. In this video, I would like to share with you, let's take that line away. I'd like to share with you about ecological study designs. Boy, that's distracting. Okay. So ecological study designs are kind of interesting because they're the primary one that we normally talk about that's on the population level. And so what I mean by population level is that we collect data for a group of people. It could be for a whole country. We could report things such as average life expectancy, birth rate, um, the percent of the population that lives in the city versus the country, all kinds of things that are just on the population level. And the only data that we have is for the whole country or state or city collectively. And so you will see this kind of data a lot in public health. A lot of the basic reports are looking at kind of how are we doing in terms of maybe comparing different cities to each other. I've seen this for schools. You could look at schools and then compare to the average overall. How are we doing in terms of passing tests? What are our demographics? How do we compare with other schools? And so the only data that we have is on the population level. And so the unit of measure is the group. And so if you were to look at a data set, each line in the data set would be for each school or each country or each state. And so it depends a lot on how the data is organized. Data are organized. So here we have our population level data. And I would say that by far and away the most common ecological study design is essentially a cross-sectional study that we are simply measuring on the population level. I would say that that's very common. It is possible to have ecological data for different kinds of studies. Um, Even experimental, we can randomize entire groups of people to receive one kind of intervention or not. And I'll talk about that more when we get to experimental study designs. But the important thing to keep in mind is that no matter what kind of study it's emulating, as soon as you get on the population level, you have a very important limitation that kind of spans every way you interpret that particular evaluation of a relationship. So the biggest limitation of ecological studies is that if we see some kind of a relationship between an exposure and an outcome, maybe in a particular city the water supply has blah blah blah, we also have data for that city on what percent of the population has a particular outcome. The relationship at the population level does not necessarily apply at the individual level. And what I mean by that is, let's say that we know that people in certain countries have a specific eating pattern. Maybe they tend to eat more olive oil than sunflower oil. Maybe they tend to eat kind of more Mediterranean versus the standard American diet. And so if we notice something about a country or a city, a population's dietary patterns, and then we say, oh, well, what's their rate of cardiovascular disease? The people who are eating a certain way are not necessarily the ones who are avoiding specific disease outcomes. Or the people that are eating a specific way aren't necessarily the ones within that population that are having that particular outcome. And so there can be a mismatch. It's what I'd like to do, because I think this was really helpful for me as I was learning about this particular kind of study, is I would like to show you an example of how this works. And I'm not going to get into too many of the details because I think sometimes that's distracting, but the general essence of this particular study had to do with suicide and religion. And so we had we looked at population level data, we looked at neighborhoods. And so within a neighborhood, I'm going to just call this religion A. What percent of that neighborhood belonged to religion A? And this happened to be in England post-war that they performed this study. And so the really religion A and religion B are Catholic versus Protestant. But I'm not going to dwell on which was which. So here we have religion A. Let's say we have 10%, 20, 30, 40, 50, 60, 70, 80, 90, or like 100% of that particular neighborhood belonged to religion A. And then we also looked at suicides. And this is usually, say, per 100,000 population, we convert, if it's a big neighborhood or a small neighborhood, so that we have a kind of a standard denominator. So here we have our suicides, and essentially what we found is as more people belonged to religion A, our suicide rate went up. And so we said, well, people who belong to that particular religious beliefs, the more of them there are, then it must mean, and actually this line can't go past here because that's 100%. The more people there are, then it must be people who are religion A who are having this particular problem with suicide. So the more people in that category, the more suicides. That seems like a logical conclusion. The problem with that is that they're looking on the population level. We're looking at the whole entire neighborhood, what percent is religion A, and the whole entire neighborhood, how many suicides did we have. And what I want to point out then is here we have religion B. Essentially, as the percent of religion A goes up, the percent of religion B gets smaller. So down here, if those are the only two possible choices, which in this case they were, we have lots of people who are in the B category and very few in the A category. So if this adds to the whole total percentage of people, then those two groups would characterize the entire community. And what we found is it was actually the people in religion B who were having this issue with suicides. And you might say, well, that's weird. When you have lots of people in religion B, you have very few suicides. Here they are, right? And when you have very few people in religion B, you have more suicides. And the answer to that dilemma, what the scientists finally discovered, is as the social networks became smaller and smaller and smaller, the more marginalized, the more unaccepted people were in their particular community, the fewer people they had that were similar to them, the more likely people in religion B were to actually commit suicide. And so as their group became smaller, suicides went up. And so that seems like a really strange relationship, but that's what eventually came out of this. And so you can see just because on the population level there's a positive correlation between religion A and suicide, on the individual level that relationship is actually the entire opposite, the exact opposite. So as you have fewer people, it's not a positive association between religion A and suicide. It's an inverse or a negative relationship between religion B and suicide because of that social isolation issue. So that is my example on ecological studies and why we have to be really, really, really careful about drawing conclusions on the individual level when we're using population level data. Now, ecological studies are super amazing, and part of the reason is we have tons of data. We have a lot of population level data that's just out there. It's readily available. It's easy to get to. We can get it from a variety of sources and use it and merge it together and use it to find this whole idea of hypothesis generating, to find hypotheses that we want to test. When we were looking at religion and suicides, it might have been, or it may even be, that for specific religious groups, we do have more or less of an issue with suicide or any health problem for that matter. So I would say a lot of the time when we find this relationship on the population level, it is also applicable on the individual level, but we cannot make that assumption. We have to then, once we've done the ecological study, we have to move on and do some studies that are hypothesis testing. So that's where we would start looking at those relationships longitudinally. So, in summary, ecological studies, the data come at the population level. The unit of measurement is a population, it's not the individual. Good examples are country or state level data, even like I mentioned, it could be cities or schools or that kind of thing that we're comparing with each other. The strength is that we have a lot of data that's available. You can see how if you just go out and look for data, then it would cost less, it would take less time, it would take fewer resources to do these kinds of studies. But the big drawback is this thing called ecological fallacy, where the relationship on the population level is not automatically applicable on the individual level. Now, the other thing that I want to point out for these ecological studies is very often, and especially in public health, we see kind of repeating these year after year after year. And we have a special name for that that makes absolutely no sense. We call it a longitudinal ecological study. Now, let that sink in for just a minute. If ecological studies are a specific kind of subtype of cross-sectional, we've just named it a longitudinal cross-sectional study. So it's kind of a contradiction, but here we are. That's kind of what scientists generally call these, and we might and very often in public health, we want to see the trend of a specific morbidity or mortality or risk factor over time. What's happening in this community or at this particular school? Remember, the individuals are changing over time. So essentially, we're doing multiple cross-sectional studies over and over and over again, and then stringing them together over time so that we can see, is the trend going up? Is it going down? Is it staying the same? So this idea of repeating a cross-sectional or an ecological study over and over again can really help us to see those kinds of things. All of that is happening in this hypothesis generating area. And so be really careful about the interpretation of studies that you really can't say a whole lot about what if certain variables are causal. So that is a summary of ecological study designs. Thank you so much for joining me.